Welcome everyone to another session of Ask Us Anything. Today we shall be unpacking dental resins, engineering resins, and some of the criteria that you would choose to select dental resins or resins for any use really. Okay. So first we're going to start with what is 3D printing resin. So there's many different types of resins available for different types of printing, but the resins we're going to focus on today is stereolithography or SLA resins. Stereolithography or SLA is also known as photosolidification or resin printing. As the term implies, photo energy or light energy is used to initiate the photochemical reaction, which causes chemical monomers, which are repeating units of the same type, and oligomers. Oligomers are repeating units of different types. And together with the activation energy provided by light, it will cause a polymerization, a polyramic reaction, a photopolyramic reaction. Resins in general are designed to be very sensitive to a few key spectra. In general, resins or light-activated resins are going to be sensitive to all sorts of light. But generally speaking, for SLA, LCD printers and resins of that nature, you will find that 395 to 405 nanometers is the ideal wavelength for SLA LCD resins. And the majority, all of the Uniz resins are 395 to 405 nanometers is the ideal spectrum for them. Okay. Another thing I would like to again reiterate is Uniz is a open system, which means you are definitely able to use third-party resins, and because the software is so you're able to actually adjust the software for many things, how long the light flashes for, how long each layer takes to print. You can make adjustments that a lot of other systems won't allow you to do for your third-party resins. Okay, so these are some of the resin criteria that often you will find in like the SDS or the MSDS sheets that you will get for your resins, right? So some of the things they'll look at is color, shore hardness, flexural strength, tensile strength, elongation, etc. So let's actually unpass this a little bit and see what all of these different factors actually mean. So first, color. Color is pretty self-explanatory, right? The color of your resin when it's printed will matter to you depending on the reason you're actually using the resin for. Do keep in mind that many resins or photo-activated resins will change color after you've actually printed them and you've actually put them in a cure box. They will actually change color, and many of them will change color drastically. So it's also important to realize what your printed color will be and perhaps what your resin color is currently. Another thing that actually gets looked upon quite a lot is the shore hardness scale. It's a scale that indicates a resistance a material has to any indentation forces, or how hard a material is. It's measured using a shore gyrometer, which is a fancy device that you can actually test different sort of materials from. And the scale for a shore hardness, there's actually two scales. There's a D scale, as it's been listed over here, and there's also an A scale. So the A scale is actually used for softer materials. So for example, you will get a shore hardness number in the A scale for some sort of elastic resin, which is relatively soft and flexible. The second scale is the D scale, and this is the scale used for harder materials. So this is how you are able to determine what the hardness of your final completed printed part is. The next thing we'll look at is the flexural strength. The flexural strength is defined as the highest stress in a material just before it fails or yields in a flexural test. So what that means is the maximum amount of tension, force, pressure that a material can take before it fails. Okay, the flexural modulus is the tendency for the material to resist bending. So right here, this one. Okay? Tensile strength is defined as the maximum load that a material can support without being fractured. Okay, so let's actually look at the show hardness scale here. So as you can see, extra soft will be in this scale right here, and then extra hard will be anything for the most part above a show hardness scale of 100 on the A scale or over 50 on the D scale. And so you can actually have a look here. So tire threads, for example, on the D scale are only about 10 or 15 strength. And that's the hard scale, right? The show hardness D scale. So tires, in a matter of speaking, as compared to some of the resins that you can print, the final products are quite soft in comparison. You know? The next thing to look at is the elongation factor. The elongation factor is essentially the length at breaking point that the material expresses as a percentage of its original length, i.e. length at rest. So if a rubber reaches twice its length before it breaks, its elongation percentage is 100% because it's twice as long as its resting state. The next thing to look at, an important thing to look at, is the impact strength. So this is one of the different types of impact tests that you can actually do. It's called the IZOD test apparatus. And basically what it does is you would put your part or a material or prototype or something that's actually printed in a material, and you would actually run this test. And this test will actually give you a definitive understanding of what is the maximum load that a part can take. So essentially it's the capability of the material to withstand a suddenly applied load, and it's expressed in terms of energy, so joules. And of course the last one, heat deflection temperature, that's pretty self-explanatory, is a measure of a polymer's resistance to distortion under a given load, or in this case temperature, at an elevated temperature. It is a temperature at which a given polymer or a given polymer test bar will bend 0.25 mm under a given load. So at any point, if it goes past a 0.25 mm or 250 micron bend or deflection, that is this temperature at which this resin is compromised, or it's starting to be compromised. So let's look at categorizing resins. So this is a categorizing of resins that I've just sort of put together and I've created, because a lot of these resins are interchangeable between the different industries and different uses. So over here, I've broken it down into 4 distinct categories. First, you have the castable resins, then you have the dental and medical grade resins, standard resins, and then the engineering resins. So it's very possible that you can use dental and medical grade resins if you wish in engineering resins, if it's got the right sort of properties, what the criteria that we just spoke about. But generally speaking, standard resins, for example, are used in prototyping, are used for rapid iterations when a designer wants to actually have a physical object that they can observe, can have a look at. You can also use standard resins in maybe architectural models. If you're an engineer and you're creating prototypes and you're iterating like non-stop, you're changing things, and you need to see how it actually works as a whole, prototyping resins is the way to go for you because they're cheap, and they will give you the volumetric space that you've designed. Next thing we can talk about is the engineering resins. These are resins that have a very specific mechanical or thermal properties, or a durability scale or a toughness scale. And so if you're an engineer, you'll understand what I'm speaking towards. For engineering resins, it's really got down to what is the part you're printing going to be used for. Is it going to be a functional part? If it's a functional part, then what is it that what are the factors that part is going to be stressed on? So temperature stress, wear stress, friction stress, abrasion stress, So these are the way you would actually go ahead and determine what engineering resins you should use for your specific use. And of course, then we can talk a little bit about the castable resins, which in our dental market, for example, castable resins would be the ones you would use to design, the metalwork framework for, PFM crowns. What you would use for if you're using digital design software, it's what resin material you use to actually print out titanium bars, for example, that you're going to be casting, or cobalt chrome work that you're going to be doing for dentures. And this is the type of resin you'd use, castable resins, yeah? And as I've indicated here, a lot of the castable resins are actually cross for jewelry as well. So over here, for example, you've got the initial 3D printed jewelry part, or the jewelry, the ring, and then over here it's actually been casted, and then over here it's been polished and cleaned up, and the stone's been added, for example. And so this would be the workflow. Now if you think about it, traditionally the way that this would have been created would have been exactly like your PFM technician. They would have actually used wax and actually built that up. And so if you can imagine how much time saving this actually has, it's incredible. So it may take one really skilled artisan to actually be able to wax this up, might take them 5 or 10 minutes. But in that time, so in the time that it would take a Uniz printer to actually print this, we could maybe print 20, 30, let's say, for example, and the technician would have actually, or the artisan would have taken that same amount of time and maybe only been able to produce 3 or 4, and we've done 30. So this is like some of the ways that you can use some of these resins. Yeah? Then of course you have the dental and medical grade resins. These are really important because the majority of these resins come with some sort of biocompatibility factor, especially if the part that's being printed is going to go into the patient's body in some form. So it's very important for dental and medical grade resins that you do keep an eye out for, and you do cross-check for the biocompatibility. And usually medical and dental grade resins will have a class 1 designation. Okay, so now we can, and class 2 would be sort of medical grade, but it's not entering the patient's body. And also the time, so for dental medical grade resins, they're only going to be good for a set period of time before they change somehow, where so let's say, for example, surgical guide. If you 3D print a surgical guide and you use it straight away, no problem. But if you leave that surgical guide for 3 or 4 days under some sort of light source, you will definitely, almost certainly, get some sort of distortion. And that is just the nature of photosensitive resins. Right. So let's look a little bit about standard resins. Okay, so these are general use resins. As you can see here, you have resins that have been used here to print this little castle towers, and it's really nice printing actually. And as you can see, in terms of SLA and standard resins, you can get a lot of detail. Another frequently used, as I mentioned, is for iterative prototyping. If you're going through a lot of different designs that you actually have to show and test whether this design part is functional or usable, is the right size, has the right dimensions, has the right design form, this is what you would use. You would use standard resins because they are by far the cheaper resins as compared to any other resins, as there's no specificity to them. And of course, standard resins would also be resins that you'd use for hobbyist 3D printing, right? So there's a lot of hobbyist 3D printing going on right now. A lot of hobbyist 3D printing happens with FDM printing, which is fused deposition printing. So essentially using a coil of nylon or some other plastic, for example, and using almost like a hot glue gun, using that as a way to actually build up your layers. But you can also use standard resins, and the sort of surface finish and quality will be bar none as compared to FDM printing, for example. And so here I've just sort of put a sequence of events that this user has actually used the resins for, his standard resins for. He's printed what looks like barrels, and then he's actually then gone ahead and characterized it by actually adding paints and colors to the point where, you know, if you didn't know better, you would think that that is a little tiny metal drum, which in fact it isn't, of course. It's a 3D printed resin. And standard resins, of course, will not come with any certifications for biocompatibility. The reason I actually bring this up is because, you know, definitely in the market, there are users who are using standard resins for sort of dental or medical grade, and you shouldn't be doing that because they've not been cleared. We do not know if there is allergic reactions, or they may cause some sort of long-term detriment to the patient, or, you know, to the client. So next thing we will actually talk about is the dental and medical resins. So with the Uniz right now, currently in this market, these are the 4 resins that are available right away. So you've got surgical guide resin, which is right here. You have impression tray resin, which is right here, and dental models right here. So this is a really interesting sort of resin. So this is one of the few, if not the only Uniz resin that actually you can get away without light curing. So you would 3D print this resin and you would give it a quick wash, and that's it. You can actually then go ahead and use it, whether you're using the dental model for crown and bridge work for fitment testing, or you're actually then pressing plastic sheets for aligner production. The good thing is Uniz prints extremely fast, and this resin is perfect for thermoforming for aligners. Do keep in mind, as with all resins, if you're printing these models for aligners, you must utilize within the first 2 or 3 days after you've actually printed them, because any longer than that, they will start to distort ever so slightly. And this is quite standard for most resins, unless you're specifically chosen a resin that does not distort after printing and been exposed to light for a long period of time. So a good example of that would be if you want to keep your model for a long time without any sort of distortion. A good example and a good use resin would be the ortho model resin from Uniz. This doesn't suffer the sort of distortion effects that the dental model suffers after 3 or 4 days. The dental model resin was primarily designed to print really quickly for a high volume lab to check for fitment on crown and bridge work, if that's what they want to utilize it for. Or it was designed for quickly print models to use for your aligner workflow. All right. So these are the available resins currently. These are the resins that will be coming soon. So Uniz has a few castable resins, but they are going to be coming out with a dental specific sort of castable resin that will be very useful for crown and bridge work, for PFM production, for, you know, your overdenture bar production, that sort of thing. Then you've got the crown and bridge resin. Now the crown and bridge resin, for example, is high abrasion resistance and strength, and it's strong, rather. So what does that mean? So basically what you're going to be using the crown and bridge resin for is going to be for teeth in your dentures, 3D printed dentures, or you would use it as a short-term, long-term, temporary crown, for example, right? So you definitely need a material which has high abrasion or resistance to abrasion, because, you know, wear and tear in the mouth. If you have somebody who is a brookser, you know very well that enamel, while it may be extremely strong, still chips. And so this is plastic, but it also has a very high abrasion resistance. So it will resist abrading as much as possible, but because it's a 3D printed resin, you can definitely just 3D print another copy if your patient requires, for example. The next resin we're going to talk about a little bit is the denture-based resin. So the denture-based resin, we're very excited for this, because we really feel that dentures are digital 3D printed dentures are the way to go, most cost effective, and you could say most accurate if you're using an intraoral scanner right now. So a little bit about denture-based resin. So it's got a low shrinkage factor, which means that what you print is what you get. It's not going to distort. It's not going to change its size. It is what it is. What you've designed is what you'll get in the denture-based resin. It's supposed to be used for long-term prosthesis or long-term denture wearing. So it's got a very high flexural strength, which means that, you know, the flexibility of the denture is there, so it won't snap. If you use a really hard substance for dentures, it can potentially snap. Of course, as well, the denture-based resin is also non-toxic and biocompatible. As I've written below, all of these resins are non-toxic, hypoallergenic, and harmless. They are biocompatible class 1 resins. The next resin we'll talk about a little bit is the bite splint resin. So this is another resin that we're really excited for because it's perfect for splints, night guards, and depending, possibly some mouth guards, really thin mouth guards. This resin is also non-toxic, hypoallergenic. It has a high elongation and durability factor, which is perfect for its use. And also because a splint sits in the patient's mouth for a really long time, another factor that's very good to note is that it's actually minimal water absorptive, meaning it will not absorb water, it will not change size. So those are really good things to actually look out for. Another sort of perk for the bite splint resin is it's available in a few colors. So depending on what your patient would like, you can have a few different colors, and accordingly you can go ahead and 3D print their bite splint for them. The next resin we're going to be talking about is the retainer resin. So this is a resin that you will be able to directly 3D print your retainers. It is a biocompatible, non-toxic, hypoallergenic resin. Once again, it has very good resistance to impact and deformation stress, which means that it's perfect for retainers. It will, it does not warp, it doesn't deform, and also to a certain extent, this resin has a little bit of a memory characteristic about it. So, for example, if you find that the retainer is deviating slightly, it doesn't fit as well as it once used to, not a problem. You can put these resins, or rather this retainer, in a glass of warm to hot water, and it will go back to its original form. So it's like a memristor, if you know what I mean. So memory metals, for example, springs are a good one. You can distort the spring beyond its elongation factor, so it doesn't actually return back to its original shape. But if you apply heat to springs, they coil back to their initial start point. So the bite splint resin has got the retainer resin has a similar property to it. And then the next resin that's going to be available really soon, and once again we're very excited for this, is the indirect bonding resin. The indirect bonding resin, for you clinicians out there, if you're unaware, indirect bonding is the concept of being able to apply brackets all at once. So for example, this is an indirect bonding tray. So what happens is the brackets have actually been placed with exactitude where they need to be on the teeth. And so basically this case was fully designed in CAD software, something similar to 3Shape's Ortho software. So the software knows exactly where you would like to place your brackets. From that, it creates a shell that has a little pouch for where the bracket should go, and then you apply a little bit of light cure bonding or light cure resin, your standard dental light cure resin, the same resin you'd use for bonding brackets in normal situations. And you would then in one go actually be able to set all of those brackets in the patient's arch at once. So generally speaking, a lot of clinicians, what they do is they actually don't go ahead and create an entire arch for an indirect bonding tray. What they'll do is they'll break it down into maybe 3 or 4 different pieces, so that it's a little bit easier to handle in the patient's mouth, as it were. Yeah, and so one more thing I'd like to point out is that, so the crown and bridge resin, for example, you will also be able to use as a bar, for example, a light, long-term, hardy bar. You can also do temporary bridges, as been seen here. So this is, as you can see, is an implant retained bridge. So what is very exciting about the crown and bridge resin, for example, is the fact that you will be able to actually use any of your composite staining kits. So we're talking things like Ceramage, for example. You'll be able to light cure those stains on this material. Or if you're using a Chauffeur Vita staining kit, for example, you should be able to characterize the crown and bridge resin materials as well. Okay, moving forward, we're going to talk a little bit about the engineering resins. So right now, at this moment, there is a ABS resin available from Uniz, and it's available in green, white, or gray colors. There is also HIPS resin, which is more of an acrylic-based resin. It's got more of an acrylic property to it. And then finally, you also have Z-ENG, so Z engineering resin. So what's the big difference between Z engineering and Z ABS resin, for example? Well, Z engineering resin provides a lower deformation rate after post-cure process than Z ABS resin. So what that means is Z ABS will shrink quite a bit more than engineering resin. So the engineering resin, because it doesn't deform, it stays with its structure after you've actually printed it. It is an ideal resin for creating high precision assembly parts, for example, that require design specs to match production specs perfectly. The Z-ABS material, for example, prints with a matte, smooth finish. There are a few shades available, green, white, and gray, as I mentioned. And the resins are strong and durable. And it's called Z-ABS because the material properties actually reflect the ABS plastic materials that you can actually get. So ABS plastic is a very often much used plastic in industrial processes. So these are the engineering resins that are coming soon. And we are very much excited for these resins as well, because the things you'll be able to do with these resins are pretty amazing. You have elastic resins. So for example, elastic resins, and I will say that these are not all Uniz printed, but these are different elastic sort of materials available, and the different things that you can actually print with elastic resins. So here you have goggles, scuba diving goggles produced with elastic resin. Here you have little wheels that I imagine will be quite soft and flexible. Here you have a heart model, which is very interesting because you could potentially pump liquid under pressure through these, and this heart print, and it should, by right, assuming you can actually get the ventricles to fire, it should react and behave, much like a heart. So, it's a very, very interesting time to get into 3D printing with some of these resins. So elastic resin will have a high resolution and low shrinkage after post-curing. So what you've designed is what you'll get. It has a lot of elongation give. It's got 120% of printed length, which means if you printed a bar, let's say that's 10 centimeters long, it can stretch all the way to a total length of 22 centimeters. That's a lot of elongation within the resin properties. And most of the times, if you keep push and pulling, push and pulling, push and pulling, push and pulling, eventually you're going to cause a strain on the material and it will break apart. But elastic resins, on the other hand, are also durable. So they are happy to be happy to be bended repeatedly. So repeated bendability. Yeah. The elastic resin coming from Uniz will have a silicone-like surface texture, and as I mentioned, you can have many uses. You can use elastic resin for soles of shoes if you'd like a really soft give-like sole to it, and of course, as I mentioned, you can also use it for swimming goggles and some of the other things here, right here. So this is almost like a hairband, like a squeegee, I think it's called, something like that, or scrunchie rather. Sorry, it almost looks like a scrunchie. So you could actually even 3D print elastic resins to use as a scrunchie. The next resin that should be coming online soon will be the resistant resin. So this is resin that is extremely resistant to high heat and abrasive factors. So this is a perfect engineering resin to print parts that are in an environment that there's a huge heat fluctuation, high heat to low heat to high heat, and also experiences a lot of wear and tear. So this would be the sort of resin that you'd use for those sort of parts. Then the next resin that we have coming online is the jig resin. The jig resin is going to be a strong and rigid resin. So it is ultra resistant to deformation. So it is ideal for the manufacturing industry, for prototyping as well, if you need that strong and rigidness about your prototype part. And it's also extremely useful for jig manufacturing, as the resin name implies. This is the perfect resin to use for jigs. In terms of the properties of the resin, it has a very polycarbonate sort of property to it. So that will be an interesting resin to look forward to. So I feel I've skipped on the ultra strong resin. So let's talk a little bit about the ultra strong resin. So right now Uniz offers the Z ABS, which is as strong as ABS plastic. But what's exciting is the ultra strong resin that will be coming out is twice as strong as ABS. So I mean, in terms of what you can use this for, I mean, the sky's the limit. If you've got a need for it, I'm sure you'll be looking out for this resin. It's twice as strong as ABS, and it's very hard and impact resistant. So this resin could constantly be hammered, and it should not, the impact should not actually cause any sort of deformation on the resin. This resin as well, surprisingly, very interestingly, also has a memory-like characteristic to it. So if you distort it, and you're able to distort it given all the properties, it will return back to its initial set point, assuming you have not pushed the resin or the part you've printed past its elongation factor or past its failure point. If you've not done that, then it should bounce back to the same sort of structure that it had before. Then we shall talk a little bit about the deformation resin. So this is soft and flexible with high durability factor. So what this means is you could potentially use this resin to print ventilation pipes, perhaps for a respirometer, because it's an elastic material, or soft and flexible material, but you can also bend it. So you can withstand repeated deformations, and it again returns back to its original shape. So what you'll find is a lot of these resins actually are starting to have this memory-like property about them, which I think is quite interesting, which means that you don't have to chuck out parts as often as you used to, because they will return back to its original shape. So if you look at the images, this is just soles been printed in a 3, I think this is a /plus. This is mask guards or face shield guards, the superstructure to build for that. And this, I believe, is printed in Z ABS white. And so for all of you guys out there who already have a Uniz, you can actually print this, because help the frontliners with PPE, yeah, if things get worse in Malaysia than they are right now. Okay, so that pretty much covers most of the new resins that are coming online. This is just, I would say, an overview and a heads up for some of the resins that will be coming. Once these resins are available in Malaysia, we will do a more in-depth analysis of these resins and what they ideally should be used for. We will have some printed parts for you to probably have a look at as well. So we've previously last week, my colleague Ross spoke a little bit about the different printers, so /plus and the /2. This week we're talking a little bit about the different resins. We've covered a little bit of how do you pick resins, what are the things you need to look out for. And what I will say is a lot of the criteria that I spoke about, these are criteria that are, I would say, more relevant to the engineers and the hobbyists out there, because you guys are printing parts for a specific purpose that will face specific in situ conditions. For the dental market and the medical market, where you already have biocompatible materials already honed in for your specific purposes, you don't need to worry too much about some of these criteria, because those criteria have that choice has been taken away from you, because of course in the medical industry and the dental and medical industry, repeatability is very important. So for a lot of those biocompatible resins, the presets have already been determined within the Uniz software. So for you guys, it's pretty much design and print. You don't have to worry yourself too much about trying to look out for the criterions as I was speaking about. So the last bit in a full sort of 3D printing or a SLA resin, LCD resin printer is the post-processing. Most resin printing requires a wash and curing process. So as I mentioned, the dental model from Uniz is one of the few resins that actually does not require any sort of post-cure at all. All you need to do is give it a quick rinse in IPA, and the resin, the excess uncured resin on the surface will be washed away. And after that, you just gotta pat it dry, let it sit for a bit till it's completely dry, and you're good to go. But generally speaking, this is not how resins work. Majority of resins, after they've actually been 3D printed, all will require a post-processing step in IPA. And this is primarily to remove uncured resin from the surface. After curing resins, after washing resins, you will have to put it into some sort of cure box. So here I've just, so this is a little DIY cure box that I found on a user group on Facebook. Here you can see that the user has just actually lined a metal bucket with LED lights, which he has then created a cover for, created a remote control for, and so on. So this is just to show you that yes, light curing can be done at home if you wish, but of course, what I will say is that the majority of Uniz resins that will be coming online will require light curing, and Uniz will be releasing a light cure box as well, and it's touted to be the strongest light cure available in the market today. So that will be an interesting development when we come to that spot. We will talk a lot more about post-processing once these new resins are available and coming online in Malaysia. So this is the Uniz ultrasonic cleaner. This is what you would use to clean Uniz printed parts. But of course, if you already have an ultrasonic cleaner within your practice or at home, you will be able to utilize that as long as you are able to fill IPA in there. And then comes the post cure. We will get into that at the next Ask Us Anything focused on the Uniz. So without further ado, would there be any questions? Let me just have a look at the live stream, just a moment. All right, looks like we don't actually have any questions, which is not a problem. What we'll do is we'll stick around for a few minutes if there are any questions. If not, and you've actually been watching this broadcast later after the live session, please feel free to send us questions or any inquiries you would have at Bio3D. At Bio3D, yep. You can use our Facebook page, or you can directly email sales@bio3d.asia. All right, thank you everybody for joining us. It was a pleasure talking to you about a little bit about our Uniz printer and our new resins that are coming online. We're very excited for that, so keep this space in view. There will be a lot more announcement and new information coming your way. All right, have a good evening, everyone. Bye-bye.